Now the next step for using the incident shader and also using the gradient shader through volume is by creating your fake subsurface scattering without using any subsurface scattering or ray marching technique. By using the incident and gradient, you're able to create to control the transparency over the edge of the object, and also to control how the actual volume, the inner volume, will react to based on the actual thickness. So this is an example of how to create your own fake subsurface scattering, which will render without ray tracing at all. It is a very simple setup that simple scanline rendering will be able to render without the need of ray tracing. So the first step here is actually to create a new material on this object here. So we'll put a some sort of a Phong, for example, and the first step here is actually to get the actual transparent to create the actual volume needed. So the first thing, we'll go under the transparency and knock off the actual surface by make it transparent, and so whenever you render, actually you'll see nothing. But that's not a problem, because what we want to do is really see the volume inside the actual geometry. So the first step is to get the scalar state. So as I said in previous session, a scalar state allows to return information, ray tracing information. So whenever it's connected to the volume, it will give the ray length, which is the thickness of the object, for the precise location or where the ray traversed the actual geometry or object. And we'll go and get a gradient shader and connect this one to the input, and connect this gradient shader directly on the volume. So now, as you can see, if I do a render region here, I'll get this some sort of thick effect here. Obviously, what we really need to do is to create a more like a constant shading. So we need to first adapt the actual thickness to make it a little bit like shade like this here. We'll edit the Phong here to disable the specular highlights just to see the actual surface here. And I'm going to actually just remove the actual light here. So let's go under scene, and I'll be deleting the eyes here. Voila. And voila. Okay. And the next step here is to adjust the actual gradient color in order to get this sense of light scattering inside. So let's go here and actually make it a little bit like blue, for example, or like some sort of a bright blue like this. You can actually adjust with the marker how thick you want the actual effect to be. So you can adjust it to have this sense of a very bright color. Actually, you can type in values that are a little bit beyond 1 to get this sense of glowing at the same time. So 3 is a little bit too much, so let's put it back to 2. Now we have shaded the actual volume. So it's not really a volume shader. It just says, okay, the volume is that thick, and the actual, based on the thickness, I will return a color, and that will shade the surface of the object. But for the for the user or somebody that watched the image, it really looks like it was a volume effect. Now the actual next step here is to let me just get this the actual shader here. So we'll go and edit the shader. Voila. Okay, seems like the actual shader is missing, so we'll connect here. Phong. Voila. Now Phong is actually being connected. We'll need to make some sort of edge transparency, and also reflection edges, and because let's say you want to recreate some sort of a glass effects, for example, well, the reflection tends to be at the border, for example. So we'll go under the region option here, and we'll disable the ray tracing. We'll go with scanline only, and that will give you an idea about how fast this effect can be, even though you don't use ray tracing. So the first step is actually to the next step, I'm sorry, is to make the surface a little bit transparent and also reflective. So now we start to see a little bit of the effect here, and we'll need to get an incident shader here. So we'll need one incident shader for reflection and one for transparency. So let's go over the reflective. So we have a scale reflective. So now we can actually kind of drive a little bit the incidence here. We really want to invert the reflection, so we need to have the reflection on the edge. Since there's really no object around, no geometry that surrounds this geometry, we'll be using an environment shader to sort of create a fake environment. So we'll connect this to the environment shader. So now we start to see a little bit of the reflection here. We'll go in Fong and use environment only, and the reason why we do this is because we really want to have no ray tracing to be used at all. We really want to have a pure scanline rendering. So now we have driven the actual reflectivity factors. We simply need to adjust it just to actually get the actual reflection to appear at the edge a little bit. Voila. Now let's go and pick into an exercise sample right here. We'll just need to use some sort of reflection map right here. Voila. That's kind of neat. Now the next step is to get an incident shader here and connect it to the transparency. So we need to get this this sort of transparent in the middle, but at the edge we want to have it a little bit more like opaque, for example. So we'll connect it directly on scale trans. Yes, exactly. That is the scale transparency. Now we see that we're shading, we're making the actual surface, the inner surface, transparent, but the edge is more like opaque. So we need to adjust this slightly, like this. Voila. Now we start to have this effect. Now we need to adjust slightly the actual specular highlights on the Fong to get this this sense of glass. Voila. And now we have this really a good result about subsurface scattering. And after that you can actually go back onto using the gradient and start to adjust a little bit of the shining that occurs onto the actual model here. So that's a pretty good trick here to render this this effect. And the reason why you see this line disappearing is simple, because there's infinite tracing levels. So if we were to close this, for example, the effect will be actually the actual inner volume effect here would go up to the bottom of the neck here. So it's simply because it's open right here. So as you can see here, this there's really no lines being shown here, and that is a proof that if you close the actual, it's a closed volume, you won't have any of these particular artifacts. So I just hope you enjoyed this session. Thanks.